Welcome everyone to the In the Field webinar series. This is brought to you by The Growing Point, which is the Alberta Wheat and Barley Commission's agronomy and extension platform. My name is Jeremy Boychyn. I am the Commission's agronomy extension specialist. I'm going to be your facilitator today. If you have been coming to these webinars over the past few weeks, this will be the first time I will be facilitating with my mustache. So I hope you all enjoy that as well. I'm here with Dr. Kelly Turkington, and thank you, Kelly, for joining us today. But before we get going, I want to give a quick introduction to the series. Obviously, the Alberta Wheat and Barley Commissions have a hands-on approach to agronomy and extension. We've been working to deliver content that's timely and driven from resource-based content. But with gatherings being more of a challenge around COVID, we thought this would be a good avenue to take to kind of link that interaction between researchers and producers and agronomists. So these webinars are focused on helping producers and agronomists stay a little bit more connected and finding another way to deliver that agronomy information. So for everyone who's on the webinar right now, I'm going to give a few housekeeping items to help you interact with Dr. Kelly Turkington and me and ask questions properly. So there are a few different options that you can interact during this webinar. There's a Q&A, there's a chat function, and there's a raise your hand. If you go to the bottom of your webinar page, there's a button that should say chat. Click that and it should pop open, and then there's a little drop-down panel that's just above where you would type your text. Right now it says all panelists. Click that and change it to all panelists and attendees. This ensures that everyone can see your question when it pops up, and they can upvote your question, and they can also have a conversation with you. So I'd highly suggest changing that right now. And if I see you type later and it's to all panelists, I'm likely going to tell you to change it so everyone else can see what you have to say. The other option is your Q&A button, which you will also find at the bottom. That's a question that's directed directly to me, and then I will ask Kelly at the appropriate time that question, and he can answer that for you. And the last option is the raise your hand option. This can be found in that bottom, or in the chat as well. Yes, I believe it's found in the chat. And you can click that button, and it allows me to give you the microphone, so you can actually verbally ask your question to Kelly if you so want to do that. So those are your three different options for interacting, and feel free to use any of them. Some of the bigger questions will likely push to the end of the session, but if you have a question specific to a slide, we'll try and address those as we're going. Lastly, feel free to join us on social media for this. If you want to share it all on Twitter, hashtag The Growing Point. We'd love to see your tweets and engagement. Feel free to tag at Alberta Wheat and Alberta Barley. And that is everything from me. So I will hand it off to Kelly now, and everyone enjoy.
Well, thank you, Jeremy. It's great to join you from home here. I just wanted to say a couple things about my background. I'm a research scientist with Agriculture and Agri-Food Canada here in Lacombe, Alberta. My area focuses on plant pathology, and especially the diseases of barley, wheat, and canola. My background with Fusarium actually goes back to the fall of 1991. I took a postdoc position in Ottawa at the Plant Research Center of Ag Canada at that time. And it was a project looking at the impact of crop rotation, tillage on Fusarium head blight in wheat and ear rot in corn. Subsequent to that, when I came down to Lacombe in about 1994-95, we started doing surveying primarily in our area, the area in and around Edmonton up towards West Loch Barhead, and then up in the Peace, looking for Fusarium graminearum because we could see what was happening in the Eastern Prairie region. So we've done a fair bit of research over the last, since really the mid-1990s here at Lacombe, and with colleagues in the province, in Saskatchewan, as well as in Manitoba. So I'm going to talk to you about trying to tweak your management program for Fusarium head blight. The primary focus will be on trying to get the most out of the fungicide application that you're using. Before I get into the main part of the presentation, though, I'd just like to acknowledge, there we go, the colleagues that I have within both the federal and provincial government, universities over the years, industry colleagues, certainly the farmers across the Prairie region, and the generous funding that we've received for a number of projects under the wheat and barley cluster. If we look at Fusarium head blight, it's a disease which affects all small grain cereals and corn. So if we look at symptoms in wheat, the typical symptoms usually occur about 7 to 14 days after infection, maybe a bit longer than that, depending on the temperature and moisture. Typically, you'll get in wheat individual spikelets on the head that are prematurely ripened. The fungus itself can move from one part of the head to the other, typically via the rachis, so the infection will progress up the rachis, or in some cases you have the production of the rain splash stage of the fungus that will splash spores to other parts of the head or maybe to adjacent heads that are not infected. The symptoms are quite distinct, typically premature ripening. You get the production of this orangish or pinkish sporulation, which is very indicative of Fusarium. The issue, though, is what species of Fusarium are you dealing with. Once that tissue is killed and is dead, then you can start to see other things that will start to grow in that. So in 2016 and 2019, many growers had some real significant challenges with delayed harvest or not being able to harvest. And in those 2 years, basically we had the crop going from a nice golden brown color to sort of a dusty gray, maybe a dusty dark olive gray color. And you can see some of this, it's sooty mold fungus, not due to Fusarium graminearum. In barley, if we look at barley, the symptoms are a little less distinct. You tend to get browning, sort of a browny purpley discoloration. You don't see the same type of premature ripening in general. And the symptoms can actually be confused with those caused by the spot blotch fungus, so kernel smudge or black point, sometimes net blotch infection, or even hail damage that results in purpling, sort of these purpley bruisings of the head tissue. So if we look at diseases, one of the things that is useful is to look at the factors that result in disease. And pathologists talk about the disease triangle, and it's important to understand the relative contribution of those three factors to development of disease. So here we're looking at the leaf spot complex and rust in wheat and barley, and the importance of the host, the pathogen, and the environment. And here you get probably the two biggest factors are the environment and the host. So the host in terms of what is the genetic resistance that the breeders and pathologists have built into that variety. Is it highly susceptible? That will greatly increase your risk. The other factor is the environment, and it's sort of like putting your foot on the gas pedal. If the environment is quite favorable, the host is very susceptible, that disease will cycle very rapidly. The pathogen itself is less of an important factor. You don't need a lot of infection earlier on in the season because of the nature of these pathogens. They're all polycyclic, so they cycle on the crop during the growing season. So if we look at that, and I apologize, there's a bit of a delay here in terms of slide advance. I'm just going to get rid of that little window there with the question. We'll deal with that in a few moments here. Oh, there we go. So if we look at tan spot, for instance, you could be out scouting for weeds in June. You could see some lesions on some of the leaves in the crop. The thing to keep in mind is those lesions, especially if they're mature, will be producing spores. And the leaf down at the bottom of the slide here shows a lesion with some of the tan spot spores. They're long, dark brown, cigar-shaped spores. And they're dispersed by wind from those infected leaves to adjacent plants, or from lower leaves to the middle of the canopy, and eventually up towards the flag and flag -1 leaf, and so on. And if you have favorable weather conditions, in the case of tan spot, heavy dews, high relative humidity can promote it. Of course, the occurrence of rainfall too. But you can have those spores germinate, infect that healthy leaf, producing a new crop of lesions. And those new lesions will produce a new crop of spores. So approximately every week, that fungus can cycle on that wheat crop. And you can follow that. The nice thing with the cereal leaf spots and rusts is you can follow that progression and use what you're seeing as an indicator of risk and whether you need to spray or not. If we look at Fusarium head blight, it's a bit of a different picture. Generally, pathologists consider Fusarium head blight to be a monocyclic disease. So you have spore production and ascospore production from crop residues. Those are dispersed from the residues up onto the head tissue where they initiate the infections. So it's one cycle of spore production, host infection. There can be a bit of a secondary spread from the rain-splashed spore stage. So if you get infections on the head tissue, you'll see that you'll get production of the sporulation from the spores. The rain splash stage is a different spore stage, and dispersal of that pathogen to other parts of that individual head, or maybe to adjacent heads. The severity of the symptoms will likely not be as significant, and we'll talk a bit about that a little later on. So in terms of the importance of the host, the pathogen, and the environment, in the case of Fusarium, the environment is probably the key factor. So moderate temperatures in that 20 to 25 C range really promote development of this disease, and of course wet conditions. The other factor is the pathogen, and you need the pathogen present, and you need it in sufficient quantities in terms of having significant issues with downgrading due to Fusarium damaged kernels and issues with mycotoxin contamination. So if we look at the disease cycle of Fusarium head blight, we'll just advance to the next slide here. There we go. In terms of the disease cycle, infected seed is a vehicle to introduce the pathogen into areas where it's either not present or perhaps present at quite a low level. You plant infected seed, the fungus grows from the seed to the developing seedling, and now you have a source of residue that can contribute to epidemics of Fusarium in future growing seasons. A small amount of infected residue is likely not going to be a big concern in terms of significant issues and downgrading due to Fusarium damaged kernels. It's only once you start to see a significant amount of infected residue within that field, and it's at that point that you'll start to see issues with development of Fusarium head blight later on in the season, and issues with downgrading and mycotoxin contamination. So if we look at infected residue, that's where the fungus survives from one growing season to the next. And this is a target in terms of management. So unfortunately, the cereal, canola cereal rotation that we have in many areas of the prairies is simply not sufficient in terms of decomposition of that infected residue. Ideally, you want to look at least 2 years of a non-host crop. Problem with that is your crop choice, your comfort level with alternative crops may not be great. So those residues produce two types of spores. On the left, you've got, in that blue is the wind dispersed spore or the ascospore, and on the right are the rain splash spore stage. So those are dispersed from the residue up onto the emerged head. They land in that head tissue, and if you have sufficient moisture and moderate temperatures, even low temperatures, let's say in that 15 to 20 range, can result in infection. It just takes a little longer, and it means you need a longer period of sufficient moisture in terms of promoting infection. Eventually you get the production of symptoms and the rain splash spore stage on that infected head tissue, and that'll splash those spores to other parts of the plant. It may not necessarily contribute to the development of Fusarium damaged kernels, but it may contribute to issues with mycotoxin contamination, so Deoxynivalenol or DON. And that infected plant tissue, whether it's the head tissue or the fungus will infect other parts of the plant, leads to production of residue. So the question that we asked earlier was, should I be concerned about Fusarium infected seed? And I would say it really depends. If you're in an area, and we're seeing fewer and fewer areas in the Western Prairie region, and especially in Alberta, where we don't find Fusarium graminearum. But if you're in an area or in your individual farm where you've never had problems with downgrading, or you've had Fusarium damaged kernels in terms of grade, but you find that those damaged kernels are not due to graminearum, they're due to other Fusarium species, or even the gloom blotch fungus, the Septoria nidorum pathogen can produce symptoms that mimic FDKs. If you haven't found it, you want to be in that situation cautious about your seed source. So have it tested. Try to avoid seed with detectable levels of graminearum. If you're in an area where you have a well-established problem, lots of infected residue in your field or adjacent fields, the concern with seed infection moves from introducing the pathogen to looking at whether that seed will perform or not. So will it germinate? Will the seedling emerge, and will it get adequate stand establishment? So it's a couple things to keep in mind in terms of the role of seed infection. So if we look at fungicide application, that needs to be done, and the ideal stage is at the start of anthesis. So typically when you see yellow anthers in the middle part of the head is the ideal stage. And we'll talk a little bit about the reasoning behind that in a little while. The problem with this is that you have to make the call to spray before you see symptoms. Similar problem in terms of sclerotinia stem rot in canola. If you contrast that with leaf spot diseases or rust, those are easy to follow during the growing season. You can monitor them, assess their development. Do you see a lot of it in the lower canopy? Is it moving into the middle canopy? Which means that you have a developing risk that probably warrants a fungicide application. Fusarium head blight, you need to make that decision before you see symptoms. So if we look at fungicides, I just want to emphasize they're not a magic bullet for Fusarium. It provides suppression at best, and really it's very, very important to focus on application technology. So listening to people like Dr. Tom Wolfe and others in terms of their recommendations in terms of the latest in spray technology. And of course, crop agronomics will help. So things like increasing your seeding rate to produce a more uniform crop, more uniform head emergence, and a more uniform target to hit with your fungicide. Head coverage will be important, so that relates back to some of the spray technology recommendations from Tom. And then obviously timing will be key issues, and we'll talk a bit about that later on. In terms of the level of control, you need to be realistic in terms of your expectation with fungicides in relation to Fusarium head blight. The level of control is about 50% roughly in the best case scenario. And in terms of DON contamination of the grain that you harvest, the level of control can actually be even less. So it's pretty hard to get a very high level of control with a fungicide only. So it needs to be combined with other strategies. In terms of leaf spots, 80% control is quite reasonable with good timing, a good product, good application, and that can even jump up to 90 to 95%. In terms of something like stripe rust, fungicides work very, very well, and we can get over 90 to 95% control with a fungicide with stripe rust. So again, to emphasize, don't rely only on fungicides. Use an integrated approach for this disease. So a word of caution about when trying to target FHB, and based on my experience in Ottawa and subsequent to that, it's a difficult disease to deal with effectively. Our tools that we currently have are not good enough. We need to improve them, whether that's crop genetics, application technologies, chemistry, or other alternative strategies. We look at what our colleagues in Saskatchewan have dealt with, and I've talked to people like Randy Kuchar and Faye Doken-Bouchard over the years. In that northeastern part of Saskatchewan, where my dad actually used to farm at St. Brew, they've had some real challenges over the last 10 to 15 years. And in their case, they're often recommended to use a resistant variety, avoid host-on-host rotations, and to apply a fungicide. So they follow all of the recommendations in terms of experts like myself recommend, and yet they still have issues. So when the weather is very favorable, you have a well-established source of inoculum on the crop residue within your field or immediately adjacent fields, you're still going to have significant yield, grade losses, and dawn contamination, even if you've used all three of these strategies. So for me, this is what makes this disease most frustrating in terms of providing tools to manage it and for producers themselves to being able to manage it effectively. So if we look at the disease cycle, flowering and anthesis is the key stage for infection. So in wheat, flowering typically starts about 3 to 4 days after head emergence and lasts for approximately a week. And that'll depend on moisture conditions and especially temperature conditions. Barley's a bit of a different animal. The flowering can actually start before head emergence while the head is still in the boot or partially in the boot, and then continues to last for about 14 days. If we look at staging your wheat, so getting prepared to make that fungicide application, so if you look at about 7 days out, you're at the booting stage. You might start to see the tips of the awns if it's an awn variety of wheat or barley that are poking out. So you're about 7 days out from that key stage for application. 6 days out, you're going to start to see more of the awns. 5 days, you'll see the boot starting to open up. So that flag leaf sheath starting to open up. You can see bits of the head there. 4 days out, you'll see part of the head coming out. 3 days out, again, continuing more of the head emergence. 2 days out, you'll probably see most of the head being emerged. And then 1 day out, you'll have full head emergence. So if you look at anthesis, that's the key stage for infection. And typically that's when you start to see the yellow anthers being extruded in the middle part of the head. So that's the key time for application of fungicide. And just another visual to illustrate that. The head in the middle is at the key stage. The head on the right is a bit too early. And there's some reasons for that. It may not necessarily relate to the fact that that tissue is resistant. Probably relates more to the fact that if you have heads in your crop that are starting to show that early emergence, that head emergence, it means that probably there's a large proportion of heads that are still in the boot or partially in the boot, and thus are not, the tissue isn't directly exposed to spores of the Fusarium fungus in the air. Conversely, on the right, we have a head at a bit of a later stage. So flowering is complete. You've got all of the anthers have released the pollen, so they no longer have that yellow color. They're whitish. And that's thought to be the end of the critical period, maybe. So if we look at why do we focus on anthesis timings for Fusarium head blight suppression? Well, if we go back to the early 1900s, and I know sometimes we feel old information is not very useful, things have changed, but the underlying biology of the crop you're growing, the underlying biology of the pathogen that you're dealing with in general stays fairly stable. So if we look at past research and current research, it's really shown that anthesis is the most susceptible stage for infection, and that the anthers themselves may actually play a role in Fusarium head blight infection. So if we look at anthers, they simply may provide a route for infection to occur. So spores landing on the anthers, growing on that tissue, and into the individual floret itself, where it can infect the developing, the ovary, the developing seed, and so on. The other thing that's been looked at is the fact that anthers may contain chemicals that stimulate the pathogen. And there's information that suggests that's the case, and other research that suggests that isn't the case. So the pathogen itself, as I've said, can colonize the exposed anthers and grow on that tissue into the interior of the floret, where it's much more easy for the pathogen to colonize tissue and infect that developing seed. The opening of the floret, so the lemma and palea spreading apart, so the anther extrudes out of it, that provides a physical opening for the spores to actually get into the interior. If they land on the outside of the lemma or palea, they may colonize that surface, but research has shown that they have a difficult time penetrating that outer lemma or palea tissue in terms of getting into the actual floret and to the ovary tissue itself. So that opening of the lemma and palea may actually provide an opening. Again, I've mentioned substances that are produced in terms of the anthers may stimulate pathogen development and promote the infection process, but that's not always the case.
Hey, Kelly.
Yes.
We got a couple questions, I think. Douglas Sell asked how many days between the second and third picture, and I think he was referring to those ones where the anther was just out and then the next photo was too late. So he's asking how many days between.
Again, anywhere from maybe 3, 4, 5 days to a week. It really depends on the temperature. So if it's hot and dry, that window will probably be quite narrow.
Okay. And then I think Colette Prefontaine put her hand up to say something. I'm going to give her the chance to talk here quickly, and then we'll move on to the next.
Sorry, guys, I put my hand up by mistake. I didn't have a question.
Oh, just throwing us for a loop, Colette. Okay, we'll keep moving on. Thanks.
Thanks, Jeremy. I'll continue on boring you. Hopefully it's not too boring. So if we look at some more recent research out of Brazil and elsewhere, they've looked at the role of partially extruded anthers, and there is some thought that there might be some variability in terms of varieties of cereals, where some are more prone to have the anthers only partially extruded. And the importance of that is that anther that's caught between the junction between the lemma and palea may provide a physical opening for those ascospores to get in and have direct access to the interior of that floret. The other thing is that extruded anther tissue may simply provide a source of tissue that the spores can land on, germinate, start to grow on, and progress into the interior of the flower. And then if we look at some of this recent research, fully extruded anthers. So you have fully extruded anthers. They're completely out of that floret, and there's just that little fine filament that attaches the anthers to the other parts of the flower of that cereal plant. That's much less favorable in terms of infection, permitting infection or promoting infection into the interior of that floret. So is anthesis, including anther production and extrusion, the complete picture? So if we look at some of the research, we can find that infections can take place without anthers or at stages other than anthesis. So if we look at some of the work done in the mid-90s by Bay, basically they removed anthers, so they had treatments where they had anthers present, they had treatments where they removed anthers, and infections occurred regardless of whether anthers were present or absent. You can also have infection between head emergence and flowering, so before anthers are actually even present and being extruded. The other issues, if you look at barley, often that flowering will take place either before or as the head is starting to emerge. So in barley, generally the thought is that infections can take place anytime from head emergence, so the head tissue is actually exposed to spores in the air, through to crop senescence. And we can have infections of other plant tissues. And the picture there is really some work that my colleague Kaquan XIAAF did as part of some research we did in the early 2000s. We're trying to understand the role that seed may play in terms of long distance transmission. So moving the pathogen from an area where it's well established to an area where it's not present or present at very, very low levels. So the fungus can grow from the seed into the subcrown internode, into the crown tissue, and progress up to, in this case, the third node during the growing season. So if we look at the research overall, it really indicates that cereal heads remain susceptible from flowering to the soft dough stage. The most susceptible stages tend to be from anthesis to the milk stage of development. Some infections can actually occur much later, towards late milk, early dough, or even hard dough. In the case of this situation, often the infections are very superficial, with little or no symptom development. The key thing is that you'll still see dawn production, and that can be an issue. So late infections can be a problem. And various studies have also illustrated that spores can actually directly penetrate that lemma, the outer surfaces of that lemma and pilia tissue through stomata. So the structures that permit gas exchange in and water vapor exchange in plants, wounds due to insect damage, gloom bases. And as the ovary is fertilized and it starts to develop, the seed starts to develop, it pushes apart the lemma and pilia. So that may provide an opening for those ascospores. So if we look at the effect of infection in general, and this is a slide from the Canadian Grain Commission, on the left we have some seed where we have infections that occurred right at the anthesis timing stage. So this is another reason why anthesis is probably the primary target in terms of fungicide application. It's to try and limit the extent of infection and subsequent development of Fusarium damaged kernels. So the most severe symptoms occur at anthesis or slightly after. As you progress to later stages where infection can occur, basically the symptoms become less and less sort of characteristic. And you can have grain that appears healthy. You're not going to see downgrading at the elevator, but if the buyer does some secondary quality control testing in terms of dawn, they'll pick up deoxynivalenol, and it may be at a level that is above their threshold. One thing we need to start thinking about is our target in terms of Fusarium head blight management. Are we looking at Fusarium damaged kernel management primarily, or are we looking at dawn management? And the timing of fungicide application has a role to play, and I'll show some data illustrating that. But an early application of fungicide may provide better management of FDK, but not so much of dawn production, because by the time the crop, in 2 to 3 weeks, the fungicide concentration in that tissue starts to decline, the pathogen can start to regrow or infect, and all of a sudden you have growth and production of the fungus and production of dawn. So it's something we need to keep in mind as far as trying to tweak our management of Fusarium head blight. Now, what about timing? And if you've listened to me blather on at other meetings, I talk about the current label recommendations, and that basically for most fungicides is the window occurs from when you have 75% of the heads emerged in wheat, 75, or in barley at 70, to when you see 50% of the main stem head showing anthers in the middle part of the head. So at that timing, if you go in at 75% head emergence, what does that mean in terms of coverage from a fungicide? Well, basically, any head tissue that is still in the boot will not be directly protected by fungicide. So the fungicide you put on needs to actually get on the head tissue itself. So that may be one reason why, if you put it on at that 75% head emergence stage, you're seeing the level of control in terms of FDKs and DON not being where you're wanting to see. So if we look at the later stages, people are concerned about going too late, but are the current label recommendations a bit too restrictive? Can we still go after the start of anthesis, maybe a week or a little bit more, and still see good levels or adequate levels of suppression of DON and FHB? There's been lots of work in the States over the last 10 years. This is some work by D'Angelo out of a variety of states. In this case, it's data from Illinois in 2013. The first slide here shows you Fusarium head blight index, so it's the extent of infection on the head itself. That bar here is the check treatment, no fungicide. Here's application at the ideal timing, anthesis, so when you see anthers in the middle part of the head, or 2 days later, or 4 days later, or 6 days later. The black bar is Prosero, the white bar is Caramba. The red line shows you 50% control. So or the level of head blight you'd need to get down to achieve 50% control. But you can see the ideal timing, we're about 25% head blight index. You can see going 2 days later, 4 days later, or even 6 days later, we're not seeing a penalty as far as management of Fusarium head blight symptoms. What about DON? Well, it's a similar picture, but you can see the extent of control. So the red line would illustrate a reduction of 50% in terms of DON level, and we're nowhere near that. But you can see that going 2, 4, or 6 days after anthesis, we're still not seeing a penalty. So keep that in mind. So if we also look at some work from Dr. Pierce Paul from Ohio State. He excellent speaker, by the way, talked at our Canadian workshop on Fusarium head blight back, I think, in the fall of 2018. And he's been involved with a large group of scientists across many states looking at fungicide application and various aspects. So he looked at timing, and here's Caramba with percent control, looking at 50% full head emergence. So you can see the level of control quite low, 50% early anthesis. So again, when you've got anthers in the middle part of the head, and the ideal timing, that sort of tail end of the recommended window of application on the labels currently, we're just over 50% control. If we go 5 to 7 days later, you can see that level of control declines a bit to about 43, 44, 45. Prosero, very similar picture. We're looking at about 30% control with that very early application, about 50% control at the ideal timing, and about 43, 44% control with the late application. So that's Fusarium. So keep this in mind. If we look at DON, it's actually the opposite trend. So definitely that very early application, you're not getting the level of control that you want or need. You need to go in at that ideal timing, or as the data is indicating, actually a little later to get better DON suppression in terms of that fungicide application. So here's the trends for Caramba, and you can see a similar picture in terms of Prosero. So there's maybe a bit of a differential between FDK management or Fusarium head blight symptom management and DON management. So we're going to move into some of the trials that are being supported by the wheat cluster. So that's funding coming from the prairie wheat commissions across the prairie region, and this is test 94. I'll go through it fairly quickly. We'll try and stay on time or close to time. So it's really looking at the impact of row spacing, seeding rate, and fungicide timing on FHB development and DON contamination. The variety we're using across Canada, except for Charlottetown and Normandin, Quebec, Charlottetown PEI, is Brandon. And we're looking at 2 row spacings. The row spacing treatment isn't at all sites, basically not at Scott, Brandon, or Normandin. But we're looking at a narrow row spacing versus a wide. And there was some recent information out of the States that suggested a wider row spacing actually may lead to more FHB and more dawn contamination. We're looking at seeding rates, so a low and a higher seeding rate, basically whether we have more variable development, more tiller development, maybe a less uniform target to hit versus a higher seeding rate and a more uniform target. Fungicide application timing, so the product we're using is Fusarium XTR. We've got a check treatment. We're going in at that ideal timing. So when you start to see anthers in the middle part of the head, on 50% of the heads in the crop, or we're going in 7 to 10 days after that application. So these are single applications, or we look at a dual, so going in at that recommended timing and then 7 to 10 days later. So if we look at some of the data, I'm not going to show you a lot of leaf disease data or yield. I want to focus more on FDK. And at the bottom, you'll see some text related to the allowable levels of FDK. So it's a percent FDK in a weight basis. So the elevators or the grain commission will weigh out a certain quantity of grain, typically 100 grams, separate out the kernels that are exhibiting symptoms of FDK, weigh those, and then use that to calculate a percent FDK. So you can see in number 1 CWRS, you're allowed up to 0.25% FDK. Number 2, up to a 0.8% level of FDK. Number 3, 1.5% FDK, and so on. So if we look at the trials, and we're just showing sites where we actually had an adequate level of FDK development and where we had some significant treatment effects. So at Melfort, our check treatment, we were well into that number 2 category with our check treatment at Melfort. By putting on a fungicide application early, we could bring that down to into the number 1 CWRS category. We could also see a similar trend with the late, and then the dual you can see tended to give us our best response, but not significantly different from that early single application. At Brandon, it really very low levels of FDK, not really of biological significance, but still a bit of a treatment effect there. And it didn't matter whether it was early or late or dual, they were all similar. Normandin, Quebec, we had a bit higher levels of FDK. In the check, just over 0.6% FDK. We really didn't see a significant response with the single applications. It was only the dual application that gave us our a significant reduction in FDK compared to the check. What about dawn? Well, we had very low levels of dawn in 2018, not a great year for Fusarium, and Melfort was one site where we had a significant, reasonably significant level of dawn and significant treatment effects. So if we look at the check treatment, we're about 0.5 parts per million with the check, and very similar to what we observed with the FTKs. The single application early gave us a pretty good level of reduction. The late application, a little less so, but significantly different from the check. And the dual tended to be our best treatment response. Now, we have some data from 2019, but it's only in terms of FDK severity. We're still waiting on the dawn data. Unfortunately, the COVID-19 situation has had an impact on that. But once we get the dawn data, we'll certainly be very interested in presenting that. So if we look at 2019, Melfort and Scott tended to have significant levels of FDK and significant treatment effects. At Melfort, it really didn't matter whether we went in early or late. The single applications gave us similar reductions, significantly lower. So we went from the check being in that the number 4 CWS category, and we could bring that down close to a number 2 with the single early, or a number 2 CWRS, the level of FDK there with the late, and then again our dual application tended to be the best. It didn't quite get us into that CWRS category, but close. At Scott, we were basically in the number 3 category with the check. We could bring that down to a number 2 with a single application. The differences with the late were not significant in terms of the check versus the late single application. And again, that dual application tended to give us our best response. So I'm just going to talk a bit about another trial. It's under the Barley Cluster Trial, and so it's supported under the Barley Cluster by the Prairie Grower Commissions and the Brewing and Malting Barley Research Institute. It's an experiment looking at trying to tweak our ability to manage FHB in crop. So we're looking at water volume 20. So that's below the recommended water volume, 40 liters per acre or 60. So that's 5, 10, and 15 gallons per acre, I think, if my memory serves me correct. Seeding rate, low and high, again, whether we have a non-uniform target or a uniform target. And then fungicide application timing is a bit different. So we're a little closer to head emergence, which tends to be some of the recommendations regarding Fusarium or fungicide application for barley. So no fungicide application, fungicide applied 1 to 2 days following full head emergence, or fungicide application 7 to 10 days after that, both of these single or the dual application treatments. So if we look at water volume, and you look at the green line and the blue line there, those are the responses at Melfort or Charlottetown. This is in terms of grain yield. I thought it might be interesting. We really didn't see much of an effect on grain yield at Charlottetown or Melfort, but we certainly did at Normandin, and a slight increase as we went from 20 here to 40. I keep pointing at the screen and then realizing that people can't see my finger pointing or what I'm pointing at.
Kelly, I have a quick question that came in regarding the last slide.
Okay.
Dean Pollack was asking if there was a row spacing significance in that wheat trial.
We really didn't see much of a significant effect there. At some of the sites, I don't know if it was Normandin or Charlottetown, maybe even at Melfort, we did see, there's certainly seeding rate effects that we saw in terms of, and that might have been related to better weed competitiveness, but not really huge responses in terms of row spacing, quite frankly. So that was 2018. 2019, similar picture, but we're still waiting on the Dawn data, so we'll have a better idea of whether row spacing had much of a role or not. So if we look at, that's water volume, just seeding rate out of interest, we saw an increase in yield with the lower seeding rate at Melfort, an opposite trend at Charlottetown PEI, where the higher seeding rate gave us our best yield, so that's more related to agronomics. And there was no effect of fungicide timing in 2018 at any of the sites. And that was probably due to the relatively dry conditions. If we look at Dawn development, so in barley, we're not looking at symptom development on the head. The symptoms on the kernels and the head tissue can be confused with so many other things in terms of discoloration, whether it's the spot blotch fungus or net blotch infection or other factors. Our focus in terms of barley, and especially if you look at malt barley production, they do look at kernel discoloration, and that's an indication of potential microbial load on the grain. But they're probably the more important focus that they have is on Dawn level. So if we look at Dawn level and water volumes, no effect at Melfort or Charlottetown, so the blue and green lines, but we did see a linear reduction, and the levels of Dawn were not high. So we went from just under probably about 0.4 parts per million roughly, down to about maybe 0.3, a little over 0.3 ppm. So a bit of a significant reduction as we increased our water volumes at those sites where we had levels of Dawn and where we had significant treatment effects. Seeding rate, no effects at Melfort or Normandin, but at Charlottetown there was a weak effect, a very minor reduction with the higher seeding rate. And that may have related to maybe less of a wider window for potential infection to occur. So a higher seeding rate, more uniform emergence, and the head emergence occurred at a time when the conditions maybe were not as favorable. What about Dawn and fungicide timing? So if we look at 2018, it was really Melfort where we had our highest levels of Dawn and where we had some significant treatment effects. Also at Normandin and Charlottetown was quite low. So we look at Melfort, that early application at the recommended timing really didn't have much of an effect. It didn't provide a significant reduction. It was only with the later application of fungicide, and there wasn't much benefit in terms of a dual application. So you can see the single late and the dual were quite similar. At Normandin, it was a bit different. It was the early application that gave us our best reduction in DON, as well as the dual application. If we delayed and went at that 7 to 10 days after, 1 to 2 days after full head emergence, we saw that fungicide didn't provide as much of a level of suppression. And Charlottetown, the levels were extremely low and we didn't see any significant treatment effects. So let's put it all together. So we've talked a bit about the general nature of Fusarium. We've talked about other things. And Jeremy, I can't remember if I've forgotten to ask the second of, okay.
That's okay, we got the third poll up.
So you can look at that question and hopefully I'll try and answer it over the next few slides here. So if we look at putting it all together, we really need to recognize that fungicide application as a standalone strategy is not sufficient. It is very different from what you might encounter in terms of spraying to control leaf spot diseases in wheat or barley, where you get very good levels of control, or with stripe rust or leaf rust, where your levels of control are very, very good. Or in the case of resistance, very good levels of leaf spot resistance, let's say scald in barley or net blotch in barley, or let's say an MR to an R for stripe rust. The risk is largely mitigated and you don't need to even consider a fungicide application. Resistance in cereals is relative. Under high pressure conditions, favorable conditions, high levels of inoculum, even an MR or an R, a variety in terms of Fusarium head blight resistance will have some damage, and it may cause some significant downgrading and DON contamination too. So if we look at fungicide application, I'm just having a bit of technology issues here, bear with me. There we go. So you need to look at crop rotations of at least 2 years between host crops, and I'm not gonna go into the challenges with that. If my dad was listening to this webinar, he obviously can't, because he's no longer with us, he would ask me, well, what the heck am I supposed to grow, Kelly? I don't like field peas. I've had disasters with that. And you stand there in your ivory tower telling me to leave 2 years between host crops. Well, Dad, it's the ideal. So perhaps over time you can move towards the ideal. You want to look at using the most resistant variety possible to try and limit that aspect of the disease triangle. Consider residue management, and that's where you're chopping the residue, you're distributing it, you're trying to promote as rapid a decomposition of that residue as possible. And that's where things like this Harrington seed destructor or comparable technologies might actually have some benefit in terms of any small Fusarium damaged kernels that get blown out the back of the combine. That technology is used for harvest weed seed destruction, but it might actually break up that infected kernel, that FDK, and promote more rapid decomposition and disappearance. Looking at the seed intended for planting, and we talked a bit about that later on, and then using good agronomics to produce a more uniform crop. And if we look at the next one, fungicide application can certainly help with leaf disease management and suppressing FDK and DON. You need to account for early to mid-season leaf disease risk. You need to look at what your target is, what your main concern. If we were talking and presenting this 10 years ago in the western parts of Saskatchewan and Alberta, your primary target would be largely leaf spot diseases. But as the situation has changed, Fusarium head blight has become more part of the disease suite that you're dealing with in terms of annual crop production. Then we can look at single versus dual applications in relation to leaf disease and Fusarium head blight risk. Now, in terms of optimal timing, there's no optimal timing, quite frankly. I think that, you know, obviously that anthesis timing, 50% showing of the head showing anthers, is probably overall the general best timing, but some of the research is showing that later applications may be something to consider. So you need to look at what the weather conditions are like as the crop is growing, what's the risk for leaf disease development, and then as you transition towards head emergence and full head emergence, what are the weather conditions like? And you can utilize the available weather-based FHB forecasting systems, which can help to guide you. I just want to talk a bit about leaf disease management and show you some results from 2019 at Lacombe. We had very high levels of scald, probably amongst the highest levels of scald. And the disease, the leaf that we looked at was the penultimate leaf, so the second leaf from the head, so not the flag. But water volume had no effect at all at Lacombe. So that's an interesting aside. I was assuming that water volume, increasing water volume, might actually promote better leaf disease management. Seeding rate had a bit of an effect at Lacombe, a bit higher levels of disease with the higher seeding rate. What about leaf disease management? And this is where things get interesting. So in our check, we had over 85% of the area of that penultimate leaf affected, very high levels of disease. We could reduce that substantially with that anthesis timing, that ideal timing, down to about 35%. Still not great, but in this situation, if I could go back in time, this is probably a scenario where you might have needed to put on a fungicide prior to head emergence, at flag leaf emergence, or slightly before that, perhaps when the penultimate leaf was coming out. And you would have seen scald developing significantly prior to that. So if you see leaf disease developing earlier, you may need to look at a fungicide application prior to head emergence. If we delayed and we go that 7 to 10 days after that initial application, and this is a single, we really didn't see much control, a little bit of a trend there. And then the dual, obviously, it was interesting, it didn't do as well as the single. So basically just some information there. What about yields? Very similar pattern. Our best responses were with the single early fungicide application or the dual, but we did see a bit of a bump with the late application too. So again, keep in mind your leaf disease risk and so on. In terms of assessing risk, we've had the availability of weather-based maps in Alberta for a few years now. It's been a little bit longer in Saskatchewan and Manitoba. These are good tools to start gauging your risk and getting prepared in terms of your fungicide program. So this is just from Lacombe in 2016. You can see, and it might be hard at the bottom, the first date there is June 25th. The last date is July 4th. So you can see it was a bit bumped up into the medium risk, sort of hovered between the transition to low and high, or low and medium, and then back into the low. So if you had head emergence around the 2nd or 3rd of July, you might think that your risk is relatively low, and thus maybe perhaps you didn't need to put a fungicide application on. It may be important in this situation to look at what your leaf disease risk is. That may be something you might want to put a fungicide on regardless of FHB risk, or look at forecasts and where things are heading. So you can see later on, as we get into about the 9th, 10th of July, you can see that FHB risk level increasing. So if we put our fungicide application on at that July 2nd or 3rd stage, even though the risk was low, we may not see much effect, because by the time you start to get into a period where the risk is higher, the fungicide concentration in that plant tissue may have decreased to a point where the level of effect is not what you'd like it to be. So these are some things to keep in mind. So in this situation, if your crop was coming into head emergence, let's say around the 5th, 6th, 7th, or 8th of July, delaying, you might have a bit longer window on the tail end of the recommended time frame for fungicide application. or if it was high right from flag leaf emergence through to head emergence and anthesis, in that situation, maybe going in right at the ideal recommended stage. So when you've got 50% of the heads showing anthers in the middle part of the head. The other the caveat, though, is that you would want to make sure to have all of the heads out in that crop ideally. That's the ideal. If there's still heads in the boot or partially in the boot, that fungicide is not providing any protection to that tissue that hasn't come in physical contact with the fungicide. So again, pulling it all together. So in terms of risk, we talked a bit about the weather system, excellent tool, but you need to also look at some other factors to keep in mind. So I would be looking at what you're seeing on your farm in general. Have I had grain downgraded due to FDK? If it's been downgraded due to FDK, and that's happened this past growing season, 2020 seed labs did indicate that a lot of the FDKs, they were seeing farmers were getting downgraded, so they took and sent their grain to 2020, and that FDK turned out not to be Graminearum. So make sure if you have downgrading, or I would say in general, send some of the grain that you've harvested to test to see what's there. What is the disease spectrum? That gives you some clues. And if you haven't found Graminearum, and your neighbor, you talk to your neighbor, you talk to 2020, you look at the Grain Commission information, and it all indicates that it's a pathogen that isn't well established or not frequently found. In that situation, you might want to be more cautious about your seed source, being very cautious about your rotation, and the focus shouldn't only be on seed infection. And we've emphasized that since the late 90s, early 2000s. Seed infection in terms of introducing a pathogen into an area where it's not present is important, but it needs to be coupled with good agronomic practices to promote or reduce the potential for buildup if you inadvertently introduce that pathogen. So what are some of the other things that we can pull together? Well, obviously fungicide application technology, and I'm not the person to talk about that. It's really Tom Wolfe at the Nozzle Guy and Agrometrics Research. So consult and follow the advice of Tom and other individuals that have that expertise to improve the level of coverage. That's probably the key thing. Increasing water volume may help to improve leaf disease management, FDK and DON. We don't have enough of our data yet to suggest yay or nay. Focus more on the mid to latter part of the label application window. That 75% head emergence is probably a bit too early because you're going to still have heads either fully or partially in the boot. Thing to keep in mind is pre-harvest intervals. So if we want to address both FDK and DON risk and management, this may require a change in mindset, regulations, and or chemistry. So we may need to look at products, fungicide products that provide a longer period of protection. So beyond maybe a week to 2 weeks, getting into that 3 or 4 weeks. And that needs to be combined with good coverage of that tissue. So right now we have single applications on the label. Perhaps we need to look at dual applications on the label, but the problem with the dual and the products that we have, they tend to be premium products, which means they have a premium price. So that's a challenge that we'll need to maybe look at trying to address. Some of the older products, like tebuconazole on its own, whether it's in Folacure or the generics, is a good chemistry. It was one of the first that was registered for Fusarium head blight. Maybe not as good as Procero or Caramba or Miravis Ace, but still not a bad product. So maybe by looking at a premium product and an older, cheaper product as part of a package, perhaps we can cut the cost. But again, I want to emphasize this is all not on the label, so it's not recommended. And you also need to keep in mind the pre-harvest intervals. So there are ample fungicide options available, but you really need to focus on using them in the right way. So the right time, the right product, the right rate, and the right technology. in terms of getting the most out of that fungicide application. And I'm just going to talk a bit about the right time and the right technology or product. So if we look at some work we did in barley, we're almost finished here. This is test 62. We were looking at the effect of seed treatment, PGR, which was ethanol, or seed treatment was ensured, twin line at flag leaf emergence, or a head emergence application with Prosero. We did have some dual applications with the flag and head, so twin line at flag, Prosero at that head timing. And this is just some dawn data from this trial over the period from 2013 to 2016. And it was a trial that ran from Beaver Lodge in the Peace to Lethbridge across several sites in Saskatchewan, Brandon, Normandin, Quebec, and Charlottetown, PEI. No effect of seed treatment, and that's not surprising. It's really having an effect on that seed and making sure that if there is an issue with either seed-borne or soil-borne diseases, that seed treatment fungicide will promote good germination, good seedling growth, and good stand establishment. What about the PGR? Well, unfortunately, in terms of ethanol, it actually resulted in a slight increase in DON level. And unfortunately, we saw the same trend with twin line. So you're probably wondering why with the PGR and the twin line? Well, with twin line, if you look at the recommendations from Europe and you look at the recommendations from the US, they're very cautious about fungicides that are either sole strobilurin-based fungicides, so the strobilurin class of fungicides, or even where they're mixed with a triazole. So this suggests there might be some caution that you need to exercise there, but our best response in terms of DON reduction overall was with the Prosero at the head. So the right product at the right stage. And I think in this trial, we weren't necessarily using the twin arrangement of nozzles, but coincidentally though, the flag and the head emergence application gave us our best levels of leaf disease management and response as far as yield and other kernel characteristics. We've done some earlier work comparing herbicide timing, and quite frankly, it just didn't cut it in terms of a benefit. It's really protection of the upper leaf canopy in terms of foliar leaf diseases primarily. So the PGR, well, why was that an issue? Well, this is just a shot from the plots at Lacombe. Can't remember what year this was at, maybe 2014 or so. But you could see with the PGR and ethanol that was at that very tight window of application, we were getting a lot of secondary tiller development. So again, a much wider window of plant development and growth stages, and so a greater risk over a longer period of time in terms of Fusarium head blight infection. So to try and pull everything together, this is my last slide here. So if we look at it, you're out scouting for weeds, you see leaf diseases, should I be putting on a fungicide? And I think if you look at the nature of the fungicides we have, the plant itself, the contributors to yield and so on, and the level of control that you have, that's a stage that you probably want to avoid putting a fungicide on. It may depend on your risk level, the client that you're serving. If you're a consultant, may be very risk averse, but the recognition is that, or the thing to keep in mind is, if you put a fungicide on at this stage and you've got lots of leaf disease, you are going to need to come back in, maybe even at flag leaf emergence, to spray. And then if you're interested in FHB suppression, you may need to put a fungicide on at that time. And that just leads to a greater risk of selection pressure in terms of fungicide resistance. So the research that we've done, people like Sherry Stridehorst and others, would suggest that herbicide timing is something that you might want to be cautious about. If you're seeing early season development, it's at that flag leaf stage, or maybe slightly before that in barley, because it's the second leaf from the head, not the flag leaf, but the second leaf and the third leaf that are the main contributors to yield in terms of leaf tissue. In wheat, it's the flag leaf and the penultimate leaf that are key. So, but if you're solely concerned about FHB management and your risk of leaf disease, you're not seeing much of it in the crop as you're scouting for weeds, as it's progressing into stem elongation, flag leaf emergence, and so on. Here you may just delay until the head emergence stage and put on that product to give you that dual benefit: leaf spot, rust management, and FHB and dawn suppression. So that's the target under those circumstances. If you're seeing a lot of leaf disease, and this might be primarily where you're growing continuous wheat or barley, or perhaps in situations where you're in a wetter environment and you only have 1 year of canola or a pulse crop between your cereal crops, in that situation, you probably want to look at that dual application, either at flag leaf stage or maybe slightly before, when the penultimate leaf is coming out in wheat, or perhaps when the third leaf from the head is coming out in the barley, and then coming back in at head emergence to top up your leaf disease control and to add that benefit as far as FHB and dawn suppression. So with that, Jeremy, I'll end there. Was there a third question? I can't remember now.
There was a third question in there somewhere, but that's okay. Kelly, thank you. For the sake of time, I want to thank everyone who attended. We do have a few questions, so after the thank you, I think we'll try and handle some of these questions.
Sure.
And then for everyone who wants to head off, feel free to come back and watch the answers to these questions. We'll be posting this webinar on our YouTube channel, so you can skip to the end and watch them all at the end if you want. But there looks like there's about 4 or 5 questions here that would be good to handle. So thank you, Kelly, and thank you for everyone who's attending and needs to leave. And we'll address the rest of these here. Kevin Oak mentioned before about rotation, and he said, how long does a pathogen last? Is 1 or 2 years in between the crops long enough? And does Fusarium head blight infect barley? And then he said, in his 5-year rotation, 2 years are cereals, which can either be wheat or barley. And he has low infection. So I guess he's wondering how big of a gap is potential to eliminate.
Sorry, so the first question was, I was sort of...
how long does a pathogen last?
So
is 1 or 2 years in between crops long enough?
If you look at some of the work done in Manitoba, this was Jeannie Gilbert, and I think with a master's student, this would have been in the 90s, maybe early 2000s. They looked at actual infected kernels on the soil surface, but it was basically at least 2 years. And then Fusarium can also survive in the stem tissue. It's not as much in the small grain cereals, as much of a prolific producer of the windborne stage. But if you look at the node tissue, it can persist for longer. So it's going to be at least 2 years. Now that means that you need 2 years of a non-host crop. And in terms of barley, if we go back to when this issue emerged in Manitoba in '93, the school of thought at that time was this was a wheat issue, probably not going to be a problem in barley or oat. As we move from the early to mid 90s to the late 90s, people like Andy Takehouse, who looked at barley and oat, basically discovered that, hey, this is going to be a big problem in barley and a big problem in oat. Maybe in oat, not as much as barley or wheat. And at the same time, you know, they were looking at what was happening in Minnesota and North Dakota and so on, where it was hitting their farmers quite heavily as far as. So all small grain cereals are susceptible to it. Wheat and durum wheat especially, and maybe some of the more susceptible types of CPS tend to be more of a problem, but under favorable conditions and a lot of inoculum, basically all small grain cereals can be hit. So that's something that unfortunately you need to keep in mind. Rotating between wheat and barley is a great option in terms of net blotch management, scald management in barley, and septoria management in general, and tan spot management in wheat. Spot blotch, a different animal, can actually affect both wheat and barley, but it really tends to be more of an issue in barley. So if you're not seeing a lot of Fusarium, you've got a 5-year rotational program, I would be definitely monitoring what I'm intending on planting or looking at purchasing to plant. I'd be looking at what I'm harvesting and testing. And again, it just gives you an indication. The approach that I've got, it seems to be working. I'm keeping this issue down at a low level. But if you start to see it upticking, maybe that's the point where you need to look at extending that rotational interval as best you can, given the cropping options that you have, the markets that you can move that into, and so on, and your comfort level with these alternative crops.
Okay, I think it's a great segue to Monica Klaus's question. Does a pathogen that infects corn pose a risk to cereal grains? If so, if the stubble emits the spores that infects at anthesis, then what type of risk do cornfields pose?
Oh, that's an excellent question. And if you go back to the early 1900s, and if you look at some of the compendiums of barley diseases, for instance, as they started to see an expansion in corn production in that region, in sort of the eastern seaboard of the States in the early 1900s, they saw a corresponding issue with Fusarium graminearum, or Gibberella Z as it's more commonly known in corn. It's the same pathogen, and pathogen in corn will attack small grain cereals and vice versa. So if you look at recommendations for ear rot or stalk rot management due to Fusarium graminearum or Gibberella Z in corn, they say to avoid planting on wheat residue or barley residue, small grain cereal residue that's had an issue. So the corn, and you look at experiences in Europe, you look at experiences here in North America, some of the research that has gone on, certainly corn production can exacerbate the Fusarium graminearum issue and Fusarium head blight. That being said, if you're looking at an ultra-susceptible class of small grain cereal, especially something like durum, it can have a similar effect. Ultra-susceptible varieties or classes of small grain cereals can also more rapidly build up the amount of infected residue. Now the question might be, what about grain? I would say in terms of corn, it's grain corn production that probably poses the biggest risk because you have the most residue going back into the field. If it's silage corn, that will help to cut the risk, maybe not necessarily eliminate it. The question though is in terms of grazing corn, and we're seeing more and more of that. And the challenge there is that in many cases, sometimes the animals don't necessarily eat all of the grazing corn. So again, it leaves a fair bit of residue in the field. The other concern that's more for the cattle operator that's using that grazing corn as a way of cutting winter feeding costs is that by leaving it in the field in August and into September, there can be growth of the Fusarium graminearum fungus. There can be growth of other Fusarium species that produce mycotoxins. So in 2016, for instance, we had some feeding issues in terms of cattle on grazing corn that were due to not only graminearum, but other species of Fusarium. So that's another thing to keep in mind. So certainly corn production, in terms of the residue that's left behind, especially grain corn production, will increase your risk, but it's similar in terms of crops like durum.
Awesome. So the gist I'm getting from the rotation piece is rotation is important because it allows that host crop residue to break down, which then the Fusarium doesn't have a host to live on, which means following crops have a lower chance of infection because the inoculum is down. Because Joseph Nichiro asks, what do you think the importance of crop rotation in mitigating against Fusarium head blight severity is?
So it's a good question, because if you look at the experience, you go back to, let's say, North Dakota or Minnesota, work that Ruth Delmackey's done and others, the rotation part of it in areas where it's well established hasn't necessarily helped, and in a broad sense. And the problem is that this pathogen produces wind dispersed spores, and the greatest risk is immediately adjacent fields. So if you have neighbors that are pushing the rotation and so on, you're maybe on a very extended rotation, you may still encounter some issues with Fusarium because it's moving from an adjacent field. I guess from a long-term perspective, and again, it involves having cropping options that farmers are comfortable with, that they have markets for, they have the technology to manage pests in, for example, Aphanomyces and field peas, that long-term, maybe we need to look at rotational systems that are 3, 4, 5 years between wheat crops. If we had, or a host crop, if we had suitable alternatives to grow, and currently that's certainly not the case. Long-term, though, it may involve collectively everyone moving to a longer rotation. And that's, everyone's different, everyone's circumstances, whether it's on-farm feed or forage needs and so on, are different. But certainly rotation is important, but you have to keep in mind that sometimes what's happening in adjacent fields especially can cause some issues.
Like everything, it's not a silver bullet, it's a mitigation factor.
Yes, yes.
So a couple questions here on the agronomy side, and I'll list them off here quickly. Travis was asking about an optimal seeding rate that's best for wheat and barley for low disease pressure while still having good yield potential.
Oh, I've worked with people like George Clayton, and John O'Donovan did a fair bit of work on seeding rate in barley. Brian Barris, obviously, one of the key wheat agronomists we have here in Western Canada. John used to talk about 300 seeds per meter squared, and if my dad was listening, he'd ask me to tell him what that is in English. So probably 2 1/4, 2.5 bushels per acre, roughly, depending on kernel size in malt barley. And that had a benefit as far as maturity, earlier maturing, more uniform crop. And then we had done a fair bit of work with Mike Edney at the Canadian Grain Commission, and now Marta Isidorsich at the Grain Commission, that higher seeding rate promoted more uniform kernel development, which meant more uniform processing in the malt plant. So it led to an increase in malting quality. So, roughly about 300, I think from some of the work that John did, once you started to get up to the 400-500 range, you started to see a drop off in yield. And that might have been due to, much more interplant competition. I'm less familiar with wheat probably, if I listen to Brian, and I don't dress as well as Brian, by the way. I don't subscribe to GQ, that magazine, the men's magazine, unfortunately, and I shop mostly at Costco. So, but Brian would suggest I'm probably in that 400 seeds per meter squared range. So you'd have to look at your kernel size, your kernel weight, I should say, and then calculate number of seeds per unit area to get to that point. But certainly an increased seeding rate does have benefits as far as better weed competitiveness, more uniform crop development, and that may have implications not only for FHB management, but end use quality of that crop.
Yeah, with the wheat side, typically what I'm hearing from Brian is that 350 to 400, and it's really going to depend on how much moisture you have, your organic matter, and this is why it's a little bit more consistent on the malt side, because typically malt's coming from regions that have, those regions are the way they are in producing malt because of their environmental conditions. So typically those seeding rates will work in those regions, but wheat, because it's grown across such a different variety of areas, in the lower organic matter areas, lower moisture, maybe a lower seeding rate is going to be more ideal for both yield economics and disease, where in the higher organic matter, higher moisture areas, a higher seeding rate is going to help out a little to a point where you're going to get those interplant competition, and then potentially an increased risk of disease with a thicker canopy like that. So there was a question about ground versus aerial application of fungicide for Fusarium head blight. Any comments on that?
That's a question that I've heard a lot about in terms of sclerotinia and canola. And as a student in Saskatchewan, a summer student, a grad student, Robin Morrell was the supervisor that I had, great fellow. And we did a fair bit of ground versus aerial comparisons, probably back in about 83, 84, 85 roughly. It all relates to coverage and water volume. And then obviously the other factor that comes into play is whether you can get into the field or not. So if it's a wet finish to June and it continues to be wet in July, it potentially could be quite difficult, if not impossible, to get in with a ground rig. And in that situation, your next best bet is aerial application. So, just based on the work with sclerotinia, and I know it's a different crop and a different disease, but it relates to coverage. And this is where maybe someone like Tom Wolf would be better placed to comment. But I think with ground, you get better coverage, potentially better penetration into the canopy from that fungicide. But if you're using aerial and you're using good application technology, maybe trying to put on as high a water volume as possible, that may provide a satisfactory level of control. But I would say, in terms of Fusarium, it might be good to chat with Tom about that and get his view, and maybe others that have had a bit more experience with aerial versus ground in terms of Fusarium. I certainly have that with sclerotinia, and I would tend to focus more on ground application in canola, and to try and get as best as possible control with a fungicide and use ground application.
Okay, thanks, Kelly. I know there's still a couple questions, Flavio and Carlene. I know you still ask questions, but if I go over an hour and a half on this webinar, I know comms will probably start beating me over the head. So I would highly suggest sending these questions to me, and we can follow up with Kelly on these questions. Flavio, it looks like it's a pretty deep question there regarding where to invest more in research and development of varieties. So send these questions on to us. I know the conversation doesn't end here, but again, thanks for everyone for continuing to follow along and stick along for an extra half an hour. And yeah, we have one more next week with Dr. Charles Geddes, who'll be talking about resistance management and scouting fields for resistance issues. So feel free to sign up for that one. And thanks again for making it to this one. Kelly, thank you so much for doing this and sharing this expertise and knowledge. I'm sure there's a lot of value that comes from this.
Excellent.
Wonderful. Thank you, everyone.
Yeah. All the best for the rest of the season.